Python 3 Functions and Modules. Code reuse. Code reuse is a very important part of programming in any language. Increasing code size makes it harder to maintain. For a large programming project to be successful, it is essential to abide by the don't repeat yourself or dry principle. We've already looked at one way of doing this by using loops. In this module, we will explore two more, functions and modules. Bad repetitive code is said to abide by the WET principle, which stands for write everything twice, or we enjoy typing. Following the dry principle makes the code easier to maintain. You've already used functions in previous lessons. Any statement that consists of a word followed by information in parentheses is a function call. Here are some examples that you've already seen. Print, parentheses, in double quotes, the string hello world. Another example would be range, parentheses, 2, 20. Then there's str, short for string, parentheses, 12. And again, range, parentheses, 10, 20, 3. The words in front of the parentheses are function names, and the comma-separated values inside the parentheses are function arguments. How many arguments are in this function call? Range, parentheses, 0, 100, 5. We have 3 arguments in there. Functions. In addition to using predefined functions, you can create your own functions using the def statement. Here is an example of a function named my_func. It takes no arguments and prints spam 3 times. It is defined and then called. The statements in the function are executed only when the function is called. So here we're going to look at a function. Def my_func empty parentheses colon. The next lines are indented because they belong to the function. We have print parentheses and double quotes spam, print parentheses double quotes spam, print parentheses double quotes spam. Then outside of the function, as you can see, my_func empty parentheses, that's the name of the function. It had nothing in the parentheses when we defined the function, so we have nothing in the parentheses when we call the function. And it's also not indented. All of those print statements are indented because they belong to the function. Here, we're just calling it, so you have to move your code over to the left. Make sure it's not indented, or it will assume that you're calling the function inside the function, but this is outside of the function. Anyway, the result is the string spam 3 times. The code block within every function starts with a colon and is indented, as I tried to explain earlier. Fill in the blanks to define a function named hello. All right, do you remember the key word to start this? It's def for define. Hello is the name of the function. It happens to have nothing in the parentheses when we're defining it, but we do need that colon. And then any subsequent lines that belong to the function will be below and indented. In this case, we have print parentheses and in double quotes the string hi. You must define functions before they are called in the same way that you must assign variables before using them. So here you see hello with the empty parentheses. That's not defining a function, that's calling a function. So this is showing you how you'll get an error if you call the function before you create it. So here's the function call, hello. Underneath it, we create the function, def hello, empty parentheses colon, and then underneath it and indented, we have print parentheses and double quotes the string hello world. Your result is shown below. You have name error, colon, name hello is not defined. So all you really need to do is swap those two statements. Create the definition first, and then below it, after it's created, then call it. and then you won't get the error. Rearrange the code to declare a function say hi, and then call it. So first we're going to create the function, so we are going to take this def say hi and drag that up here to the top. Then we are going to put an executable statement here that belongs to the function print, parentheses, double quotes, the string hi. So notice it is indented. It's underneath and indented. Then we are going to call say hi. Afterward, it's not indented. It goes back to the left. And it's just the name of the function, say hi. And when we define the function, there was nothing in the parentheses. So when you call the function, there's still nothing in the parentheses. Function arguments. All the function definitions we've looked at so far have been functions of 0 arguments, which are called with empty parentheses. However, most functions take arguments. The example below defines a function that takes 1 argument. So let's look at this new function. Def, again, that's a keyword we're using to define a function. Print underscore with underscore exclamation is the name of the function. A little lengthy, but that's the name of the function. And in parentheses, we have a single argument, word. Single thing in the parentheses, word. After which we have a colon. And then we put the body of the function underneath and indented. This function only has one statement that it executes, and that's print, parentheses, word, plus the string and exclamation point. Okay, so outside of that function definition, we're going to call it 3 times. So the name, again, is print with exclamation. So we have print with exclamation, and in parentheses, we will, instead of word, we will use whatever we want. In this case, the first call is going to replace word with the string spam. And then we're going to call it again, print with exclamation, parentheses. This time we're going to replace word with the string eggs. And then we're going to do it a third time, print with exclamation, parentheses. Instead of word, we're going to replace that with the string Python. So when you look at the body of the function, it says print, parentheses, word plus exclamation point. Whatever we replaced word with when we called the function, which we replaced it once with spam, once with eggs, and once with Python, the value to word is what we replaced word with. And so down here in the result, you see that when we ran that function 3 times with 3 different arguments that replaced word, we had spam, and we had an exclamation point concatenated onto the value of that. Then we had eggs with an exclamation point, and lastly we had Python with an exclamation point. As you can see, the argument is defined inside the parentheses. What is the result of this code? Def print underscore double parentheses x colon, and under that and indented we have print parentheses 2 times x. So outside of the function definition, we're going to call that function print underscore double parentheses 3. In the parentheses, we are replacing the x with a 3. And if you look into the body of the print double function, we are going to print 2 times x. So because we replaced x with a 3, when we run this function, our output is going to be 6 because 2 times 3 is 6. You can also define functions with more than one argument by separating them with commas. So let's look at this. We have def print underscore sum underscore twice. And in parentheses, we have x comma y. Then we finish the definition of that function. Well, we're not finishing the function. It's actually the beginning of creating the function, but we have the colon, after which we go down a line and indent any statements that we want to execute when we run this function. So we've got 2 statements here. We have print parentheses x plus y, and then we have print parentheses x plus y again. So now, outside of the function, we're going to call the function, because when you call the function, you're actually running it at that point. Print sum twice, parentheses 5, 8. The 5 replaces the x, and the 8 replaces the y. The result is 13 on one line and 13 on the following line, because print x plus y is going to print 5 plus 8. Fill in the blanks to define a function that takes two arguments and prints their multiplication. So we're going to define a function. So do you remember what that special keyword is? DEF, short for define. The name of this function is provided for us. It's print underscore mult parentheses x comma y. X and y are the arguments. We have to remember our colon on that top line. And then the body of the function, we have a single statement, print parentheses x times blank. Well, we want to print the multiplication of the x and y, so the directions would be to print x times y. Function arguments can be used as variables inside the function definition. However, they cannot be referenced outside of the function's definition. This also applies to other variables created inside a function. So let's check out the example for this. Let's look at the function def function parentheses variable colon. The statements that belong to this function, there are two of them. The first one is variable plus equals 1, and then we have print parentheses variable. All right, now outside of that function, we're going to call it. So here we call function parentheses 7. So the 7 is replacing the word variable here. And what happens is we're calling the function, which if we look back inside the body of the function, we have variable plus equals 1. Well, we replaced variable with the number 7. So 7 plus equals 1 means the value of variable is now going to increment up by 1. So variable will have a value of 8 at that point. Then when we have print parentheses variable, we're going to print 8. Okay, the function parentheses 7 will give us the result of an 8 on a line. Now, the very last line of code that we have here, we have the print command, and in parentheses we use the variable keyword. Now, we're going to get an error here because we're trying to use a variable that was created inside of a function, and we're trying to use it outside of the function, which is a no-no. So when we have print parentheses variable, that line of code gives us name error, colon, name variable is not defined. Technically, parameters are the variables in a function definition, and arguments are the values put into parameters when functions are called. What that means is when we defined the function, what's in the parentheses when you define the function is considered the correct word for what goes in that parentheses are parameters. And then when you actually call the function by putting outside of the function, when you call it because you want to run it, whatever you put in the parentheses to replace the function definition's parameters. So for instance, function parentheses 7 replaces variable. That 7 is technically considered the argument. Variable is considered the parameter. 7 is considered the argument. Fill in the blanks to define a function that prints yes if its parameter is an even number and no otherwise. So we're going to define a function. Don't forget the DEF keyword. The name of this function is given to us, and it's called even. The parameter is also given, a single parameter called x, and then we've got a colon. Then we drop down and indent to put the body of the function. So we have if x modulo 2 equals 0, colon. So what we're wanting to know, whatever value is put in to replace x, if you can divide that value by 2 and end up with a remainder of 0, then we're going to do something. So that's going to mean that the number provided to replace x will be an even number. So if x modulo 2 equals 0, we want to print the string yes. Well, we also want to do something if that's not true. So we use the else keyword, else, and also the colon. Else, and underneath the else, we also indent, print, parentheses, double quotes, the string no. So print yes is indented because it belongs to if x modulo 2 equals 0. But the else is not, the else doesn't belong to the if. If that if is false, it's going to bounce down to the else. So that else is moved to the left. It's no longer indented, like print yes was indented inside of if. Else is directly underneath if, and then print no is indented because it belongs to the else portion of the code. Okay, sounds confusing, but once you do this a million times, it's not confusing anymore. All right, let's look at returning from functions. Certain functions, such as int or str, short for string, int, short for integer, return a value that can be used later. To do this for your defined functions, you can use the return statement. For example, def max, parentheses, the parameters x, comma, y, colon. Then underneath our function definition, we have an if-else statement that is the body of the function. So we have if x is greater than or equal to y, colon. The statement that belongs to that if is return x, so it's indented. Now we get out of that indentation with an else, colon, and then the statement that belongs to the else is indented again with return y. So that's the definition of the function. So now we're going to get out of that by going completely to the left again, all the way to the left, and we have a print command, which inside of the parentheses for print, we're going to use the max function, and inside of max, we are going to replace x and y with our arguments, 4 and 7. 4 will replace x and 7 will replace y. You have two sets of parentheses here. You've got the outer parentheses that are butting up against the command word print, and then you have the inner parentheses that contains the arguments to that function, 4 and 7. Okay, so that was one line of code outside of the function. Then we have we are going to call the function yet again. On the right-hand side of that equal sign, we have max, which is calling the function, and then in parentheses 8, 5. So on the right-hand side of the equals, we are calling the function with two different arguments, but then we're using the single equal symbol to put the value of that function call into a variable called z. So then on our last line of code here, we use the print command to print out the value of z. So if we look down at the result, the first line is a 7 because we are printing the maximum of 4 and 7. And then we have max using 8 and 5. The result of running the function max between 8 and 5 is going to yield 8, which is going to go into the variable z. So when we print z, we're printing not z, but the value of z, which is 8, which is why you see 8 on the next line. All right, the return statement cannot be used outside of a function definition. So that's something to keep in mind. Alrighty. Fill in the blanks to define a function that compares the lengths of its arguments. and returns the shortest one. All right, so def shortest string, shortest underscore string. In parentheses, we have the parameters x comma y, a colon, and underneath and indented, we have if len parentheses x is less than or equal to len, oops, didn't spell that right, parentheses y, then we're going to print x. Wait a minute. Fill in the blanks to define a function that compares the lengths of its arguments and returns the shortest one. No, not print x. I apologize. We just learned about the return keyword. Okay, so I'm sorry. It's not print x, it's return x. Else, colon, return y. All right, so that was my mistake. Once you return a value from a function, it immediately stops being executed. Any code after the return statement will never happen. For example, def add numbers, parentheses, x comma y, colon. Total equals x plus y, return total. Print, parentheses, double quotes, the string. This won't be printed. Okay, so for the function add numbers, we've got 3 statements in there. We've got the first statement, total equals x plus y. The second statement, return total. And the third statement, print, this won't be printed. When you call the add numbers function, and in this case, we're using the print command to output whatever the value of this function call is. So you have print, parentheses, the name of the function, which is add numbers, followed by the arguments that replace the parameters. So 4, 5 to replace x, y. You can see the result is 9, but you don't have a line of code underneath 9 that says this won't be printed. This is just showing you that once you put the return keyword, the return statement in your function, make sure that you do everything that you really want to see output before that return statement, because as this is proving to you, anything after the return statement is a waste of your time. It will not happen. What is the highest number that this function prints if called? All right, so let's take a look at this function, def print numbers. It's got no parameters, so we have an empty parenthesis. It's got a colon, and after the colon, we have a bunch of statements. We have print 1, and then we have print 2, then we have return, after which we have print 4 and print 6. Okay, remember we just learned about the return statement. Once you use the return statement, any code that you have in your function after that return statement gets ignored. So the highest number that this function will print will be 2. Comments and docstrings. Comments are annotations to code used to make it easier to understand. They don't affect how code is run. In Python, a comment is created by inserting an octothorpe, otherwise known as a number sign or hash symbol. All text after it on that line is ignored. For example, x equals 365, y equals 7, octothorpe, this is a comment. After that comment, we have print, parentheses, x modulo y, after which we have another comment, octothorpe, find the remainder. And the next 2 statements are comments as well. Octothorpe, print, parentheses, x, floor division y, and octothorpe, another comment. The result is simply 1. because all of those little statements that follow the hashtag or octothorpe symbol are for your benefit as a programmer only. It's not executable code. Print x modulo y means print 365 divided by 7. And modulo means remainder only. So if I do, where is my calculator? If I do 365 divided by 7, I get 52.1428 blah, 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 as an answer. The remainder is 1, but I don't know how to do this calculator to show that the remainder is only 1. But you see here that there's a decimal of 1.42 blah, blah, blah. That's just reminding you modulo only gives you the remainder. Anyway, so our result here is just showing you 1. Python doesn't have general purpose multi-line comments as do programming languages such as C. So with Python, you're only dealing with the hashtag symbol for your comments. And you have to use a hashtag for each and every line of code that you're going to comment out. Fill in the blank to comment out the text. Okay, octothorpe, or better known as the hashtag. Hashtag printing X. Doc strings, otherwise known as documentation strings, serve a similar purpose to comments as they are designed to explain code. However, they're more specific and they have a different syntax. They are created by putting a multi-line string containing an explanation of the function below the function's first line. All right, interesting. So we create, let's look at the creation or definition of a function here. Def, shout, and in parentheses there's a single parameter called word, and then after the colon, this is where, before we even put the statements that execute in this function, we're putting the doc string here. And it looks to me like we have 3 double quotes. It looks like there's 6 little slashes there, so I'm going to think those are 3 double quotes, which gives us 6 slashes. And we have print a word with an exclamation mark following it, with another 6 slashes created with 3 double quotes. And then we actually have the statements that we want this function to execute. In this particular function shout, we only have one statement, and that's print parentheses word plus exclamation point, a string, exclamation point string. Outside of the function, we're going to call the function to make it work, to run it. So we have the name of the function shout, and then in parentheses, we are going to replace the parameter word with our string spam here. So the result, when you run it, is the word spam with an exclamation point after it. Unlike conventional comments, doc strings are retained throughout the runtime of the program. This allows the programmer to inspect these comments at runtime. Well, let me try it myself and see what that means. All right, so here we've got the code playground. And down here at the bottom right, we have the run, so we can see what the output is. It's taking a second. All right, I'm only seeing the output. I'm not seeing the comment. So anyway, okay. This allows the programmer to inspect these comments at runtime. Well, I guess I thought that meant I would see these comments in the output, but I didn't see them in the output, so whatever. All right, can a doc string contain multiple lines of text? Why, yes, it can. All right, functions as objects. Although they are created differently from normal variables, functions are just like any other kind of value. They can be assigned and reassigned to variables and later referenced by those names. So let's look at that. We have def multiply, parentheses x comma y, colon. There's a single statement for this function. It's return x times y. Outside of the function, which you know it's outside of the function because it's no longer indented, we have a equals 4, then we've got b equals 7, then we have operation equals multiply. All right, so on the right-hand side of the assignment equals symbol, we have multiply. On the left-hand side, we have a variable that is going to hold the value of calling multiply. It's kind of curious, though, because we have the name of multiply, but we don't have arguments after it. But when we go down to the last line of code, we have the print command, and in parentheses, we are using the word operation instead of multiply, and the word operation actually does use arguments to replace the x and y. Here, it uses the variables a and b, which before we called the function using operation, we gave a and b their own values. So a and b have the values of 4 and 7. So when we use operation AB, it's like we are using multiply for 7, which is going to give us a result of 28, as you can see at the bottom. The example above assigned the function multiply to the variable operation. Now the name operation can also be used to call the function. What is the output of this code? Def shout with a parameter word, colon, return word plus the string exclamation. After the function, we have speak equals shout. So now instead of calling the name, the function name shout, we can use speak to do the same thing. So speak is an alias for shout. After which we have the line of code that says output equals speak, parentheses the string shout. So now we've created yet another alias. First we have the name of the function called shout. Shout gets an alias of speak. Speak is used to call the function with an argument. The string in double quotes shout replaces word. Running that function is going to give us the value of shout with an exclamation point, which is going to be held in the variable output. So now output is yet another alias. So then when we use the print command and in parentheses we've got that variable output, we're going to get the result of shout with an exclamation point. So got like a lot of alias things going on here. A lot of assignment statements, if you will. Functions can also be used as arguments of other functions. All right, so here you can see we've got two functions because you can see the def keyword used twice. The first function is def add with parameters x and y. After the colon, we have a single statement, return x plus y. Then we have another function called do twice. So we have def do underscore twice, and in the parentheses we have func, comma x, comma y. And then we have a colon, after which we have a single statement, return func, parentheses func, x, comma y, in parentheses, comma func, parentheses x, comma y. So this is getting real nice and confusing. All right, after that function, we have a equals 5 and b equals 10. So these variables are given values. We use the print command, after which in parentheses we call do twice. And for do twice, we replace the parameter func with a function name, in this case add. And we replace the x with an a, which has the value of 5, and we replace the y with a b, which has the value of 10. So if we let's see, how can I explain this? I'm really not sure the best way to explain this. If we called do twice and it only did it one time, you would have 5 plus 10, right? Which is 15. But because this function is actually doing it twice, I believe we're adding the 15 plus the 15. Oh my goodness. Which is giving us the result of 30. I wish I could explain it better than that, but this is what I'm going to go with. As you can see, the function do twice takes a function as its argument and calls it in its body. Fill in the blanks to pass the function square as an argument to the function test. Okay, so we have two functions here, square and test. So remember, you have to use the def keyword to define the function. Def square parentheses x colon return x times x. And then in the second def test parentheses func comma x. Don't forget your colon. And for the test function, you have print parentheses func parentheses x. Okay, so there's two functions that are created. And now we're going to call test by using the name test. And we have to replace test's parameters, which func and x are the parameters for test. So instead of the keyword func, we're going to call the square function, so square, square, and then we have a comma here. 42 is going to replace the x. Okay, so we did that right. Okay, let's go over modules now. Modules are pieces of code that other people have written to fulfill common tasks, such as generating random numbers, performing mathematical operations, etc. The basic way to use a module is to add import module name at the top of your code, and then using module name.var to access functions and values with the name var in the module. For example, the following example uses the random module to generate random numbers. So at the top of your code here, you see import random, and then you've got a for loop here. For I in range parentheses 5 colon, value equals random dot randint parentheses 1 comma 6. And then lastly, we have print parentheses value. The result here is we have 5 outputs, 5 lines of output, and each line picks up a random integer between 1 and 6. So you have 2, 3, 6, 5, 4. So you can run this code over and over again, and each time you should get 5 lines of output, and you should have any random number between 1 and 6. The code uses the randint function defined in the random module to print 5 random numbers in the range 1 to 6. Which module is being used in this code? Import math, num equals 10, print, parentheses, math dot squirt, short for square root, parentheses, num. So which module is being used? Well, if we go back and look at the module we just learned about, import module name at the top, module name.var to access functions and values with the name var in the module. So import random uses the random module. So import math uses the math module. There's another kind of import that could be used if you only need certain functions from a module. These take the form from module name import var. Var stands for the variable. And then var can be used as if it were defined normally in your code. For example, to import only the pi constant from the math module, do this: from math, import pi. Then you can use print parentheses pi, which gives you the result 3.141592653589793. Use a comma-separated list to import multiple objects. For example, from math, import pi, comma, squirt. Imports all objects from a module is that symbol, the star symbol, the asterisk symbol. For example, from math, import asterisk. That means you're going to import all objects that belong to the math module. This is generally discouraged, though, as it confuses variables in your code with variables in the external module. So you kind of want to know what you need from a particular module and try to focus on importing just that. Fill in the blanks to import only the squirt and cos, square root, and cosine functions from the math module. So from math, import sqrt, short for square root, put a comma, and they gave us the cos, which is short for cosine. Okay. Trying to import a module that isn't available causes an import error. So here's the example. Import, and this is totally bizarre, but import sum underscore module. So it's a random name that doesn't exist. If you do that, the result will be import error, colon, no module named sum underscore module. All right. What error is caused by importing an unknown module? Well, let's see what they called it again. It's an import error. Import error. You can import a module or object under a different name using the as keyword. Okay, so we're going to play with aliases again. This is mainly used when a module or object has a long or confusing name. So, from math, import squirt as square underscore root. So if you don't want to use squirt, you want to use square underscore root so that it's more obvious to you. You can use that as keyword to give yourself the alias here, And then when you use the print, parentheses, square underscore root, parentheses, 100, square underscore root is going to do the same thing for you if you were to have used SQRT, which results in 10.0. What is the output of this code? Import math as M, print, parentheses, math.squirt, parentheses 25. Okay, I'm going to say we're going to get an error because we used import math as M. So further in the code, instead of using math, we should be using the alias, which is M. So we should get print, parentheses, M dot squirt, parentheses 25. Okay, so that's my guess. If you use the as keyword to create an alias, then you need to use that throughout your code. That's my guess. And I'm right. Okay, the standard library and pip. There are three main types of modules in Python. Those you write yourself, those you install from external sources, and those that are pre-installed with Python. The last type is called the standard library and contains many useful modules. Some of the standard library's useful modules include string, RE, which I'm not sure what RE is, date time, math, random, OS, multiprocessing, subprocess, socket, email, JSON, doctest, unit test, PDB, argparse, and sys. Tasks that can be done by the standard library include string parsing, data serialization, testing, debugging and manipulating dates, emails, command line arguments, and much more. Python's extensive standard library is one of its main strengths as a language. Fill in the blanks to import the math module. Oops. Import math. Some of the modules in the standard library are written in Python and some are written in C. Most are available on all platforms, but some are Windows or Unix specific. We won't cover all of the modules in the standard library. There are simply too many. The complete documentation for the standard library is available online at www.python.org. What name is given to Python's pre-installed modules? The standard library. Many third-party Python modules are stored on the Python package index. And here that's showing you PyPy, which is PYPI. PY for Python, PI for package index. The best way to install these is using a program called pip. This comes installed by default with modern distributions of Python. If you don't have it, it is easy to install online. Once you have it, installing libraries from PyPy is easy. Look up the name of the library you want to install, go to the command line. For Windows, it will be the command prompt, and enter pip install and then your library name. Once you've done this, import the library and use it in your code. Using pip is the standard way of installing libraries on most operating systems, but some libraries have pre-built binaries for Windows. These are normal executable files that let you install libraries with a GUI the same way you would install other programs. It's important to enter pip commands at the command line, not the Python interpreter. What does PyPy stand for? Python Package Index. Module 3 quiz. Fill in the blanks to define a function that takes two numbers as arguments and returns the smaller one. Well, we have to use the def keyword because we're creating a function. So we have def, the name is given, min, and the parameters are given, x, comma, y in parentheses, colon. Now we have an if-else statement. If x is less than or equal to y, if that's true, don't forget your colon, then we will indent return x. Outside of the if, we have the else, colon, in which we will return the value of y. Rearrange the code to define a function that calculates the sum of all numbers from 0 to its argument. Okay, so we're going to define a function, so we're going to leave the def sum parentheses x as the first line. We want to define a function that calculates the sum of all numbers from 0 to its argument. All right. I'm going to say the return res is going to stay at the bottom because, as we learned earlier, anything after the return statement will be ignored. So you don't want any lines of code to be underneath the line that's using the return keyword, okay? So we start off with the def as the first line and the return as the last line. We just have to put everything in order in between. I'm going to say we create a variable called res, which I believe would be short for result. I believe we're going to set that to a 0. Then for I in range x, colon, we will use res to increment up by 1. By I. Okay, I is going to be used to represent the value of each element in the range. So for I in range, whatever we give for x, we want to add each subsequent element of the range. So when we have res plus equals I, result is going to initially be 0, and then it's going to add the next number in the range, and it's going to keep going in that loop until it gets to whatever the range top is, whatever value x is given. So it might be 0 plus 1, and then plus 1 would then plus 2. 1 plus 2 would be 3. 3 plus 4 would be 7, and so on and so forth. So this function should calculate the sum of all numbers from 0 to its argument. All right. I might not be very great at explaining this, but I'm learning as I'm going along. All right, Module 3 quiz. How would you refer to the randint function if it was imported like this? Okay. From random, import randint as rnd_int. So we would refer to randint as the alias that we're creating with that as keyword. So we would not use randint, we would use rnd_int. So how would you refer to it? From random, import randint. Random would be the module. Dot rnd_int would be the object that belongs to the module. So I think that that's right. The only other thing that it would be is if we don't have to include the module name, then it would be the middle one. How would you refer to the randint function if it was imported like this? Oh, I was wrong. Okay. Well, I know why I was wrong. From random, import randint as rnd_int. When we use the from random, and we don't need to use the module name then. We would just have to use rnd_int. That should be right. Okay. All right. What is the highest number output by this code? Def print nums parentheses x colon for I in range parentheses x colon print parentheses I return. Then we call the function print nums and we replace the parameter x with the argument 10. All right, so realizing that our range is going to be 10 instead of x, for I in range 10 means range 10 means 0 through 9. Range 10 means 0 through 9. I represents the 0, the 1, the 2, the 3, the 4, all the way to 9. And so the highest number, when you call print nums parentheses 10, should be 9. And I'm wrong. Okay. Let's see. Why am I wrong? For I in range Let me try 10. Oh, no, it's not going to let me do 2 digits. Okay, you know what I'm going to guess? I'm going to guess 0, and I'll tell you why. If range parentheses 10 means 0 through 9, and in the for loop, we print the very first element in the range, which is 0, does the return keyword stop everything else from happening? Oh, that doesn't make sense. Oh, but it does. Okay. The return keyword stops anything else from happening. It will print the first element in that range. And nothing else. That's confusing, but it's what it is. What is the output of this code? Def func with a single parameter of x, res equals 0, for I in range x, colon, res plus equals I. Okay, so we are going to have a for loop here, which is going to increment res, res starts off at a value of 0. It's going to increment the value of res by the value of I. Okay. So when we print func replacing x with 4, let's see what the func function will do when we replace x with 4. All right, for I in range 4. Range parentheses 4 means a range of numbers from 0 to 3. The first iteration of the for loop changes res. Res starts off as 0. Then we're adding the first element of that range, which is 0. So res equals 0 plus 0, which is still 0. Goes back to the for loop and does it for the next iteration, which will be 1. So 0. So then res is going to have a value of 1. Then it's going to go to the next element, which is a 2. 1 plus 2 is 3. So res now has a value of 3. 3 is the next element. 3 plus 3 is 6. So I want to think that our output should be 6. Yay, I was right. Oh man, great. Okay, continue. Okay, so that finished the quiz for functions and modules. The next thing we'll go over is Python 3 exceptions and files.